Good morning, children. In today's session, I am going to take computer science for 5th standard, and we are going to start with the first lesson today. That is, the lesson name is Computer Fundamentals. Okay, children. Now, those who have the book, you can take the book, children. That is page number 1. We are going to learn about the computer fundamentals. Now, first we'll see the features of a computer. A computer is an electronic device widely used for manipulating data. Manipulating, that is, using or managing data based on a list of instructions known as program. Okay, what is program today? A computer is an electronic device. You already know it's an electronic device which is used for manipulating data based on the list of instructions given in the program. Now, computers can handle enormous amount of data at a time. Enormous means many amount of data at a time. They can make logical decisions. Logical, that is reasonable. Okay, logical decisions and execute multiple jobs. Multiple means many. It can bring out many jobs, and the salient features that make computers unique are. So, 5 points are given there. Okay, children. So, first, what did I say? A computer is an electronic machine used for manipulating data. Then, that is in the list of instructions given, known as a program. Then, computers can handle many enormous, that is many amount of data at a time. Then they can make logical decisions, that is reasonable decisions, I said, and can execute multiple jobs, many jobs. And the salient features that makes computers unique, that is different. Unique means different. Are first they have given robustness. What is that? Robustness. So first we'll see what is this robustness. Okay, children. The computers have the capacity to function 24 hours a day. 24 hours a day means that is 1 day. 7 days a week means that is 1 week. And 365 days a year, that is full year. So the computers can function for a full year. That is 24 hours a day, 7 days a week and 365 days a year. That is, it can perform a function for the whole year. Then reliability. So what is second one? Reliability. Reliability. So what is reliability now? Computers can perform complex tasks. Complex means difficult. Okay, complex means difficult. Difficult tasks without making human type mistakes. So if humans make mistakes, okay, very difficult. So any calculations is given, human make mistakes, but the computers do not make. When it is given difficult task for them, for the computer, the computer did not make any mistakes. So it does not make human type mistakes, such as mistakes caused by lack of concentration. So if we lack concentration, if our concentration is not there in what we are doing the work, we'll make a mistake. But the computer does not do that. It does not lack a concentration, energy or your memory. Okay. So the computer does not make mistakes like the human makes a mistake. So it does not lack the concentration, energy or the memory. Okay, children. The next is versatility. Next is versatility. Okay. Versatility is computers allow easy duplication. Duplication, that is copying or modification of data. So computers allow easy duplication or modification of data. Computers can perform multiple, that is many tasks at the same time. So computers can perform multiple tasks at the same time. Okay, each, that is one time itself many tasks you can perform. Then we'll go to the next, speed. Next is the speed. Okay, in the speed, computers perform complex computation. Complex means what I said, difficult. Complex computation, that is calculation at a very high speed. So it can perform complex calculation or the difficult calculation at a very high speed. High speed, you know, near sikrama mudikadu. So computers perform complex computations. Complex computations means what I said, difficult calculation at a very high speed. Okay. Next is lack of boredom. Lack of boredom. Okay, so lack of boredom is computers perform repetitive tasks. Repetitive means again and again. Okay, repetitive tasks without getting into boredom. So if the humans do the same task repeatedly, that is what happens, we get bored, right? So same way, but the computers which will perform repetitive tasks without making bored. Okay, that is called as a boredom. So without getting into boredom. So First, what we saw, children? Robustness. Second, reliability. Third, versatility. Fourth, speed. Fifth, lack of boredom. So first, what we saw, robustness. That is, robustness means that is the computers have the capacity to perform their function the 24 hours a day, 7 days a week, or the 365 days a year. Right, children? Now, reliability, what we saw, that reliability can perform complex, that is difficult tasks without making human type mistakes. So humans make mistakes, but the computers do not make mistakes and they do not lack concentration, energy, or the memory. Okay, children. Next is versatility. That is, computers allow easy duplication or the modification of data, easy copying of data, and they can perform multiple tasks at the same time. Then speed, I said, that is complex computation, what is a difficult calculation at the very high speed they can do. Then lack of boredom, that is computers perform repetitive, that is again and again tasks without getting into boredom. That is called as a lack of boredom. Okay, children. These are 5 salient features that make computers unique, or we saw this. Then we will see parts of a computer. Parts of a computer. Okay, children, now we are going to see the parts. Now, a computer consists of 3 basic units. How many? 3 basic units. Okay, children. Now, they are input unit, central processing unit, and the output unit. What is the first one? Input unit, and the second one is central processing unit, that is otherwise called as a CPU. Okay, we CPU only we called as a central processing unit, and the output unit. Okay, children, what are the 3 basic units, that is parts of a computer? First, we are seeing the 3 basic units, that is a input unit, CPU, that is central processing unit, and the output unit. The first we will see the input unit. So there are 3 basic units. The first we are going to see the input unit now. The input unit accepts data or the instructions into the computer. So what is the work of the input unit? It accepts the data or the instruction, you can say, into the computer. And the keyboard is the most commonly used input device, that is keyboard. Keyboard is the most important input device. Okay, device is the input unit accepts data or the instructions into the computer. And what is the important device used there in the input unit? That is a keyboard. Okay, children. Now next we'll go to the CPU, that is central processing unit. Now CPU interprets instructions. Interprets explains the instructions. Okay, instruction processes the data, that is a procedure, and stores the results. After finishing the data, what happens? Naturally, you store the result, right? So what is the work of the CPU? It interprets the instructions, explains the instructions, processes the data, and the result is stored. Okay. Now CPU is also known as the brain of the computer. CPU is otherwise known as the brain of the computer. So what is the other name for the CPU, children? Brain of the computer. Okay, right? Brain of the computer. So CPU is otherwise known as what, children? Brain of the computer. Again and again I am telling it, CPU is known as the brain of the computer. Then CPU consists of control unit, arithmetic logic unit, and memory unit, that is CU, ALU, and MU. Okay, CU, ALU, and MU. What is CU? Control unit. Then ALU is arithmetic logic unit, and MU is memory unit. Okay, children. So what are the CPU consist of? CPU consists of control unit, arithmetic logic unit, and the memory unit. Now first you will see the control unit. Okay. Now we are going to see first now control unit. So CPU, what is this, children? So other name is the brain of the computer. Keep in mind. And then now we'll see the CU, that is the control unit. Okay. We're going to see the now control unit. Now the control unit controls and coordinates the activities of other units. The CU is also known as the nerve center of the computer. Nerve center of the computer. Okay, children. So the control unit is otherwise known as the nerve center of the computer. Okay, children. It's otherwise known as the nerve center of the computer. Then the CU directs the input to the memory unit. So what it's doing first? It directs the input to the memory unit. Interprets the instructions. Interprets what I said, explains, interprets the instruction and transfers from one to another. Transfers the data from the MU to the ALU. Okay, from the memory unit to the arithmetic logic unit for processing the data. Right, children? So it transfers the data from where? From the memory unit to the arithmetic logic unit for processing. Then after processing the data, CU stores the results in the MU. Okay, what happens after processing? What happens? The CU stores the result in the MU, from where it is sent to the output unit. From there it is sent to the output unit, that is CNR, children. CU directs the inputs to the where? To the memory unit. Here the interprets the instructions and transfers the data from MU, okay, from MU to the ALU for processing, okay, for processing. Then what happens? After processing the data, the CU stores the results in MU again. Okay, CU stores the result in MU. From there it is sent to the output unit. Okay, children, do you understand this now? That is, CU directs the inputs to the memory unit, that is MU memory unit, and interprets the instructions and transfers the data from the MU to the LU for what? For processing. And here CU stores the results in the MU. From there it is sent to the output unit. Okay, children. Now next is the arithmetic logic unit. Next we are going to see the arithmetic logic unit. So AU, arithmetic logic unit. Okay, children, ALU, that is arithmetic logic unit. Here the arithmetic logic unit performs the arithmetic operations like addition, subtraction, then multiplication, then division. So it performs all this arithmetic. Arithmetic means mathematics, right? Arithmetic operations like addition, subtraction, multiplication and division on the data. The ALU also makes logical decisions and performs comparisons based on the data values. So not only the arithmetic operation, but also it makes a logical decision, that is reasonable decisions, and performs the comparisons on the based on the data. Then next is the memory unit, that is MU, memory unit. Okay, children, so memory unit is, that is, a memory unit stores data, instructions and final results. It stores, what does it stores? Data, instructions and final results. Okay, final results given. Okay, it stores the data, instructions and the final results, that is MU. The memory unit can be divided into two types, that is primary memory and the secondary memory. Two types, that is primary memory and the secondary memory. That is two types of memories. What are the two types, children? That is primary and the secondary memories. Now they have given one, see your children, in the center, one box they have given is to understand it easily. That is C Here is a input unit. Okay, children, input unit is given there, and here is a output unit. That is, input feeds the data, and the output data displays, that is, shows the results. It gives the results. Okay, children. So that is input and output. Input feeds the data and the output displays the result. Then if you say take CU, that is directs the operation. CU directs the operations. Next is the ALU, that is arithmetic logical unit, performs arithmetic and logical operations. Then MU, what does the MU do? MU stores data and the program. Do you understand, children? So input unit, output unit. So input is the feeds data and the output unit displays the result. Then CU does the direct operations. ALU, that is performs arithmetic and logical operations. Then MU, what does the MU do? Stores data and the program. So we saw this in the, that is in the input unit, that is input unit we saw central processing unit, that is CPU. Then in the central processing unit, what and all we saw, what are the three control unit, arithmetic logic unit and the memory unit. Now we'll see the output unit. The output unit presents a results of computation. Computation means what I said, that is calculation. That is this gives the results of the calculation to users. To users means that is to us, right? The output unit presents the results of computation to the users. The output unit serves as a communication. So what is the work of the output unit? It serves as a communication. Communication means that I am talking to you. This is a communication. Same way in the computer, it communicates a link between a CPU and the users. So we are the users and the CPU. There is a communication. That's a link. Okay. Link as a communication link between the CPU and the users. And monitor is the most commonly used output device. So monitor is the output device. Monitor is the commonly used output device. Okay, children, in the input, keyboard is a common device, and here in the output, monitor is the most commonly used output device. Now, let us understand the functions of some of the input and output device. So, the functions of the sum of the input and output device we'll see in the next class, children. Okay, so till here we have finished input and output. Now in the input functions and output functions we are going to see in the next class. Thank you, children.